The third lecture in Chapter 2 on collecting good data is some probability sampling methods that help us collect that good data or evidence. Now, when you see the word probability, what that is saying is there's chance. I'm not going out and selecting. These objects or people ended up in my sample due to chance. The people did not pick, nor did I. And the first is a simple random sample. We abbreviate that capital S, capital R, capital S, SRS for simple random sample. And the easiest way to explain this is when you draw out of a hat. Everybody's name is in the hat, and I select people. Everybody had an equal chance of being part of my sample. What this does is it removes human choice. We cannot select who's going to be in our sample. It has to be done randomly, by chance. And there's a way to do this on your calculator and a table on page 100. We'll do the table on page 100 together, and I'll have a separate lecture for the TI-83 calculator if you happen to own one. How is this done? Random numbers are used. So we're going to have some sort of random generator, and there's one on the internet. There's also this table that we're going to use on page 100. And what happens is everybody's assigned a random number. So let's go ahead and look at the table on page 100. We're going to select 4 objects using a simple random sample from a total of 20. So the first thing is we need to label our units. Since all of them, since we're going up to 20 and some of them have 2 digits, all of them must be assigned 2 digits. So we're going to have 01, 02, and so forth, so that we understand they all have the same number of digits. If I was going to 100, I'd have to go 0, 0, 1. We're going to go to the table on page 100, and we're going to use row 5 in the table, and we're going to select 4 objects. So if you go to your table, row 5, I see 37570. 37570. Because each one has a 2-digit number, the first one I would select is number 37. 37 does not exist, so we skip it. The next would be 57. Again, I do not have a 57. So I continue. The next is 39975. 39975. So the next 2 digits in a row would be 03. 03 then would be selected as the first subject or object in my sample. 99, not a match. 75, not a match. And you continue until you get the number that you needed. I needed 4. That's a simple random sample. The next type of sampling technique is a stratified. And if you think of strata are layers. And that's what you're going to look at. You're going to look at subgroups or layers within the population. When we look at layers in the population, we're going to take a sample from each layer. So it might be that I have male and I have females. Those are my strata or my layers. What I'm going to do is I'm going to take some males to be in my group and some females. How am I going to get those males? I'm going to take them out of that subgroup randomly. And the females will also be taken out of that subgroup randomly. But I'm looking at subgroups and picking from those. It might be that my subgroups are seniors, juniors, sophomores, and freshmen. And I'm going to take from each of these groups randomly. And that's a key. Why would I do this over simple random? Well, what if I wanted to have males? I needed to have males in my group to represent the population. If I did a simple random sample, I could feasibly get all females and never be able to get a male in my group. So when we use stratified, we're making sure that we get from each group. We collect some for our sample for each group. Now, when would I take a larger sample from one layer versus another? Well, when I take a larger sample, that strata had large variability, meaning within the strata they had a lot of differences, so I would take more to represent all those differences. When do you form the strata? How should the variability of the units within the stratum compare to the variability between? Within should be small. Within the strata, we want small variability because they themselves should be homogeneous because I'm taking from each strata. Between strata, there would be much larger variability. Is a stratified random sample a simple random sample? No, it's not. We explained why. I do use a random number generator to collect from each strata, but it's not a simple random strata because I am getting some from each strata. And that's an important thing to note about stratified sampling. It's used often. Systematic sample. This is when I take every kth person. Sounds confusing. It's just a count off like when you were in phys ed and they counted 1, 2, 1, 2, 1, 2. You were numbering system. You were numbered off. Why would we ever use this? It's fast and it's convenient. One thing we have to make sure of so that we eliminate bias, there is no order in the list. Meaning the list cannot be ordered. For example, if I was to do airline and seat number 1 was first class, there's order to that list. So we have to be real careful of that. And then we've got this idea of cluster. Cluster, if you think, is a whole group. So we're going to select an entire group, and this entire group looks like a mini population. And so to do that, the group is not homogeneous. There are lots of differences within the group. So how do we do this? Well, we use a random number to select the group. So maybe what we have are grades 1, 2, 3, and 4. And I want to take a cluster. Each grade is its own little cluster. I have 4 clusters. So I'd randomly select which grade to use as my sample. And this happens in testing all the time. We test in the K-12 at the 4th grade. We take all 4th graders because they look like a mini population. They're of all economics. They are all different genders, female, male. And they're all different ethnicities. So they look like an entire population within the 4th grade. So we would randomly select one entire group, not from each grade. That would be stratified. We take one entire grade, the whole group.